being fair? Two things. Uh, First of all, nobody can guess the outcome before it happens. We shouldn't be able to guess that carrot would be the most chosen thing, right? We shouldn't be able to guess that 3 will be the most common number chosen. If we did this experiment in another classroom, we would know. Like if we were to walk over to the South class and do this experiment, we would know what the answer was going to be. We would know that the most common outcome is going to be 3. Right? In fact, maybe I'll even talk to you just to be kind of to see if it shows up, right? But we would know that this would be 3, and we would know that going in, which means those situations are no longer, those outcomes, excuse me, are no longer random. We know that they seem to be random, but they're not. When we want things to be fair, usually some underlying set of outcomes will be equally likely. We think that in like table games, poker, that kind of thing, that fairness means that everything is equally likely. If you were to play a game with a room, a card somewhere in a deck, whoever has a high card wins. You want to make sure that everything is well shuffled, so that it's equally likely to be fairness typically means that all outcomes are equally likely. So as a quick example, let's get that. So this tendency for things to be random can be a hindrance. It can be unpredictable, it can be haphazard, but as statisticians, we don't think of things as randomness as being that. We use randomness as a tool. We need to use randomness because when we're gathering data, we ourselves have realized that if we were to pick and choose people to do something, we would inevitably use our internal biases and we choose the wrong people. We wouldn't choose a representative set. So we need to use randomness as a tool. We're going to use randomness to choose things for us so that they are random. But getting truly random things is actually can be surprisingly difficult because it's not easy being random. Generating random numbers, even when they're equally likely, is difficult. Computers are a popular way of doing it, but computers are actually not completely random. They're pseudo-random. We can make calculators not be random. And so we can only do so much with the randomness here. So let's actually show that now. You guys want to take the calculators out? here, right? And there was what, 10 of us that had random numbers, 99154. We all told the calculator to do 5 random numbers, and it came out the same 5 random numbers. Again, how many was that? We used to do 99154. Out of 20? You think that's a coincidence? Probably not. How many of you guys know a little something about computer programming and know how to do this? What do you know? Right. So good random number generators take what's called a number table, and it's just a list of 1,000 numbers in a row, right? And it's internally programmed into the computer or calculator. Okay. And a good one will try to replicate randomness by going to a random place on that list and choosing random set numbers, or to continue to go to different places. This calculator is not a sophisticated random number. Our calculators, the way they do random numbers, they've got a list of 1,000 or so numbers on a table internally programmed. And when we say, give us 5 random numbers between here and here, it starts at the beginning of that list, and then it just gives 5 numbers from that, right? It just goes 99154 are the first 5 numbers of the random number. Okay? That's why 9 of us in the classroom had the exact same thing. You might have noticed that I reset this calculator right before I did it. When I reset the calculator, it starts over at the beginning of the random number. You guys who all got that? Your calculators have either been reset recently or you've never accessed the random number table. You reset it. Every time we start something, we reset it. You guys with new calculators, brand new ones, over at 99154, it says that the new Nicole, so that says that brand new calculators, so that's like a next gen. Brand new calculators use the same random number table as the old place. Right? They haven't updated. So, is this random? You know, it's kind of random in that if you only had one calculator and you were just doing that one, you didn't know where in the number table you were, it's just random numbers. It's just as good as random. But is it actually random when we have 9 of us doing the same thing? Probably not. So this one reaches, so computers have this kind of weird middle ground where we're kind of random and they're kind of not random. The word for it is pseudo random. Right? They're pseudo random. I keep taking 10s out of this thing and I drop them off. Pseudo random. You've never felt pseudo before. Pseudo random is what these are called. They're pseudo random numbers because they're pretty much random. If we had no knowledge of the other calculators in the room, we would assume that these 5 numbers are random numbers. However, having knowledge of the other calculators in the room means that we can manipulate the random. If I know that the beginning of the number table is 99154, and I do something, I can go to the beginning of the number table, or I can go to a place in the number table where I am certain that I'm going to see it. I can go to it. But it's not really random. It's pseudo random. It gives the appearance of random, but it's not perfect. So, computers use random number tables. As it turns out, you have a random number table in the book. In the back pages where the tables are, you use for it. we have a random number table app. You guys have whatever you use. Also, if you get on Google and you would type random number table, there are random. In fact, when you are programming something in the computer and you need a random number table, there's programming functions that are designed to call a random number table. We use excellent question. So there are ways to get relative random numbers. You may do it in a way that would not be rolling dice better than a random number table. And in fact, if you could create your own random number table by rolling it for the non-gamers and right? Non. Well, they're all. Okay. But there's different kinds of um, rolling dice. Good way to get through randomness. Sometimes pulling random, like random cards from a deck, really random. What else? There's lots of ways to get through. That's one way you can do it, yeah. Or you could just be like, I want 1,000 random numbers, so I'm gonna roll it 10,000 times. Right? It would be kind of annoying, but you have a truly random number. I think so. I would guess. I actually don't know how online ones do it. Uh, yeah, I don't know. I don't know how they do it. All right, it's 53. That's a good place to stop, I think. Um, next week. Next week, we're going to use this idea of being truly random, and we are going to create simulations of random